There's that one. We had a problem like it on the quiz. And part of the thing about quizzes is the reason I let you correct them, and then if you do better on the test, you get even higher grade, is because the quiz is all about just gauging what you know and making sure you understand. So there was a question like 4A. Some of you guys had one that was like 10% strongly agreed and so forth. So you don't focus on the percentages. That's what somebody did with the data. The data there would look like what? What would the list of data look like for 4A? Blonde, brunette, so forth, right? Bald, green that day. So, exactly. Percentage is what somebody did with the data. That would be the statistic or the parameter. That's not the data. The data is the blonde, the hair color. So that would be what level?
Nominal.
Nominal. Kick ass.
So 30% of them were blonde is nominal?
Because the data is hair color.
Thank you.
You're welcome.
And then 4C, that one's doing.
Oh yeah, so what you do, so again, what would your list look like? How would you get an average number of TVs? You must have a list of numbers. You've got 3 TVs. You've got 5, right? You've got 2. You have none. You with me? So that would be your list. Now give yourself a couple of things. Like if I had 2 and you had 4, 4 minus 2 is 2, you have 2 more. So it's at least what level? What level would that be where subtraction makes sense? It's at least interval, but what do I have to rule out? Ratio is real quick. What does 0 mean on my list? The absence of TVs. So 0 means what it's supposed to mean. So right there you know it's ratio. But also if you had 4 and I had 2 TVs, 4 divided by 2 is 2, you have twice as many. The 2 I get when I divide makes physical sense. Right? When I divide years I get a number, but it doesn't make physical sense. Is that cool? So you've got to kind of go through that, give yourself a couple of easy example data points and see what the hell you could do with them. Yeah?
How do you determine how many classes you use in finding public?
Oh, the number of classes you could use?
Yeah.
So if I give you, like on number 1, that little list of data, if you used more than 6, that's too many. I mean, it's 5 or 6. It's small. In fact, 5 should be what you use. The larger it gets, the more relevant it would be to use 6 or 7 or 8. 9 and 10 would be if it's really pretty big. There actually is a rule. There is a mathematical rule using natural logs. I forget if the book even says anything about it. But why? I mean, this, the hell.
And what do we round to when we find relative frequencies?
I would round to the first place. Because the next thing you got to do is do it by hand, and you go on more than 1 decimal place by hand. I can't even capture 1 decimal place worth by my ugly hand. So, but for the purposes of just checking easier, go to 1 decimal place. If you add them all up, it should be relatively close to 100. Yeah.
Could you give an example of data that would be interval but not ratio?
Yeah, example was just what we said, the year you were born. So the year 0, does that mean the absence of time? Time has not happened yet. That is the beginning. No, because there was time before what we call 0, right? So that automatically cuts it out as being ratio.
Okay.
I wasn't born, let's see. I can divide my birth year by your birth year, but that I'd get a number. It wouldn't mean a damn thing, right? If I took the dashes out, I could divide my social security number by your social security number. Wouldn't mean anything.
So division doesn't make sense.
Yeah, you could get something, but it doesn't make any sense. It doesn't make any physical sense. But the key thing there is the 0 doesn't mean what it's supposed to mean. Yes?
Can you show an example of that?
Okay. Well, I mean, we got the number 1 there, right? What's the lowest number there? So I make a stem of 2, and then there's 30s, 40s, 50s, 60s, right? Even if there's 0 somewhere, you still put it there. Exactly, and you can kind of be smart about it. You can kind of put them in order as you go, or not. Doesn't really matter. But if you do, it just makes all the rest of the problem easy. Yeah.
Why is it that we don't use commas for the stem and
Because we just don't.
just don't? Okay.
I mean, technically, it doesn't really matter, but it's just not part of the convention of it.
Okay.
Yeah, so you weren't there when they decided not to, so you couldn't speak up for the comma. Yeah.
How would we label that? How would that get labeled?
Oh, yeah, so you have to have a key, right? Is that what you mean?
Yeah.
So you just have a little key like that.
Okay,
2-9 means
so like on
29.
the test, that's all we need to write?
Yep. Because it could mean, if you don't say anything, I don't know if this means 0.29, it could even mean 209, it could mean almost anything.
So
So you have to tell me.
The T is, we don't need to write any like units or anything like that?
No, don't. Yeah. Yes. Yeah, or, sure.
For number 1 again, G, when we're finding a 5-number summary and creating a box, do you want us to just like input the data and then go in our calculator, it says Q1, minimum, and then make the box? Is that it? Or are we actually supposed to solve for like...
What do you think? I'm the guy that owns a shirt that says what?
What?
So, yeah, I own a shirt that says show your work. So when in doubt, show your work. So it's a really good note to know, I showed you that so you can check your work,
To solve it?
but I got to see the work.
Can
Right.
you show me how to do it?
Yeah, sure.
Yeah.
You want to,
I'm being serious, yeah, I don't know how to do it.
all right.
Pick up all the problem ones in and figure it out.
Well, I already did. That's the problem. I mean, I've got the answer key.
Oh, okay.
Okay. I got this front one, I got the bottom one.
Well, if I had a list of data, all right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's make it 12. Right? Q1 would be what percentile?
25?
25th percentile.
22.
And the 2 steps, first step is find out where the answer is. Second step is go get the answer, right? So how deep in the list? The list, thankfully, I've given it to you in order. Otherwise, none of this makes any damn sense. If you can put whatever you want to, then these could be whatever you want them to be, and that doesn't make any sense. So Q1, P25, how deep do I want to go to the list? 25%. And how big is the list? It's 12. So I want 25% of 12.
3.
Yeah, so 1/4 of 12 is 3. When you get a whole number, what do? Average the third and fourth. Anything else, you round up and you grab that number. Okay, so what's the third and fourth number?
8 and 11.
8 and 11, so you average those together. And you get 9.5. Cool. So for this list of data, Q1 would be 9.5. So forth. Then Q2 would be P50. Take half of 12 is 6. You average the 6th and 7th. That would be Q2. If you did what's P41 here? What's the first step to find P41?
Yeah,
41% of 12. What's 41% of 12? Somebody help me out.
4.92.
Good. 4.92. That's not a whole number, so what do? Round up to 5. So the 5th number is the answer, right? Don't tell me 5's the answer. That's why I say the second step is go get the answer. That tells you where the answer is. 1, 2, 3, 4. 12 would be the 41st percentile. If this would have been 4.12, I would have rounded up. You always round up here to the next one. 4 isn't far enough if it says 4.12, so you go 5, just to be careful. Man. Yes?
Okay. Why did you average the first one and not the second?
What do you mean?
For
Oh, this was P25. The answer here for where it is came out to be a whole number.
okay.
So then I take it and average with the next one. Anything else that's not a whole number, you round it up.
And then you just take that number.
Then just take that number. So real quick, if I want to find the median of 5 numbers, I know the answer's in the middle, right? Well, what's 50% of 5? What's half of 5? 2.5. Rounded to the third one, that's the answer, right? You kind of with me?
Yeah.
Cool. And now if I want the median of 4 numbers, where would the median be? The average of the 2 in the middle. Half of 4 is 2. It's a whole number, second and third. Average them. See, so percentile is a more general median. So anything I do to find the median is somehow going to be related to what I do to find any percentile. Cool. Yes?
Oh, I just need that paper.
Oh, the practice test.
Yeah.
Okay, you're lucky. That's my last.
Thank you.
Copy. Yes?
Of
course, that's my last copy. What's the problem? Which one are you looking at? Oh, the one asking for the percentiles? Oh, 1D. Yes. And I need that for the homework too. Some of you guys are getting some homework back. It says, correct mistake, show work. So chapter 3, I actually need to see. You don't have to show me, don't be a dork about it and show me. But show me sum of x over n. Show me what the sum is divided by n. Show me the work, how you got to it. Cool. Same thing on the test. Yes?
Can you go over z-scores and how to find the z-score?
Sure.
Thank you.
Let's see. So z-scores. Who remembers the question I'm definitely going to ask you? And there was an example of it on the practice test. What does the z-score mean? Or I might say, what does the z-score of 1.89 mean? Right? For a data point. So what do z-scores mean? So it means, so I have to see something, and I don't want you to just, I want you just to make sense. A z-score just measures the number of standard deviations from the data point to the mean. That's what a z-score does. Z-score measures the number of standard deviations from the data point to the mean. So it's like measuring how many inches are between me and one of you guys, right? Inches would make sense, miles would not. So since we're relatively close, my standard deviation, inches make sense to use as a measurement. Or feet, if you're way back there. So somewhere in the middle there. You kind of with me? So that's the idea. Standard deviations are the tick marks. Z-scores are laying the ruler down. The number of standard deviations between the mean and something. And if it comes out negative, it just means that data point is below the mean, right? So if you had a negative z-score in your test, that means you scored below average. Positive above average. 0 would mean you're exactly average. Yes. So the z-score formula, what the hell is that?
X minus X bar over X.
In fact, as soon as we're done with this problem, I'm going to take a little break and show you guys what can be on your formula sheet. Yes, you can have a formula sheet for the test. If you're going to turn it in with your test, and I always, for some reason, have like 10 people that lose points on their formula sheet because you have examples and shit. It's a formula sheet. You can't even have any words except the word like mid-range. It doesn't have a symbol. You with me? So don't try to sneak in any empirical rule shit, make up your own little symbol. No, none of that. Right? You can only have formulas. So we'll do that here in a minute. So if I had a problem, what kind of distribution does it have to be to use z-scores? That's a trick question, just to let you know right now. What was the answer? No. Any distribution. You can find a z-score for any distribution, doesn't matter. I can know how many standard deviations is away from the mean. Normal tells me I can use empirical rule, so if I am the one away up and down, I have what percentage in between, within one step? What percent? 68%. Don't be careful of chubby dude. And yes, you do have to know empirical rule. You have to know 68, 95, 99.7. Right? You have to know that for the test.
68.
No. Hell no. It's not a formula. Don't try to argue it is, because it ain't. And if you make the case that it is, I'll say that's not allowed on there anyway. So if I give you a mean of 12 and a standard deviation of 1.98. Yummy. What's the z-score for a data value of 14.7? All right, now tell us how you got that. Neato, what'd you put in there and why?
I put 14.7 minus 12 divided by 1.9.
That's silly. That's exactly right. So you put the data point minus the mean. So that's how far away your data point is from the mean. Divided by something tells me how many of these fit in there. That's what division means. How many of these things fit into there. So that's why the definition makes sense. How many steps from this to that? Now on the test, be careful. Don't say steps. I'm going to say steps in class, and I mean standard deviation. So when you mean standard deviation, say standard deviation on your test, right? When you say steps, I'm going to be be more specific. And then you'll say, but you say steps, and I'm going to, So yeah, if you do this, what do you get again? I'm sorry, I forgot.
1.3636363634.
Cool, okay. I like it. So it's roughly that. And what does that mean about the data point?
It's 1.36 steps away from
Yeah, so it's 1.36 standard deviations away from the mean. And it's positive because it was above it. So if I made a z-score for 7.1, before I do any work, I know it's going to be negative because it's below the mean. Okay, good.
How would you like us to phrase that on the exam? So would you like us to say,
No. You say something that is what it is. I love that answer I just gave you. I would
But
really
you said
rather,
steps.
your guys are going to memorize some phrase I've given you, and it's always been a little bit different every time I said it, so that's fine to a point. I'd much rather you understand it and just be able to say it in exactly your own words, and that, of course, is the most hated phrase in college, in your own words, right? I understand that, but the more you understand it, the more you should be able to convey it to me without having to memorize something. But if you do memorize something, that's better than not doing anything, right? So that's fine. But it's I desperately want this to make total sense, because a lot of the course after starting in Chapter 6 is going to be totally based on this and the understanding of this. Okay. So, one thing you can definitely have on there is this, right? The first, and no words, so let's do this from the beginning. It's really nothing in Chapter 1. Chapter 1 is all definitions. Chapter 2 is histograms, frequency distributions. You got to know how to find the class width. I don't want to see that formula up here. You got to know how to find the class width for a histogram. You with me? How do you find the class width for a histogram? Range divided by number of classes. Cool. That'll tell you how wide the classes have to be. If you get 1.8946, don't use that. Please round it to 2. Please. Okay. Chapter 3 is where we get our first stuff. So we get the mean for, and the book uses big ass N, but I wish they didn't. Okay, so those are simple. You might not even need to write this down, but you might as well. And then we get standard deviation. Yes, ma'am. Yeah, what is that for?
That's for population.
Population, I love it. Do not put the word population down. No. You'll get points taken off for that. No words on here except for the ones that are part of the formula.
If we do the chart like we did on that homework and we put population and what it's supposed to be sample, we're going to get marked down for that, right? It's like the same thing, but...
Oh, yeah, obviously, yes. I don't want to see any of... All right, this is off the... I always have somebody that has this somewhere.
Yeah.
No, it's not a formula. You got to know how to set up your table, right? So no, just no. Only what I have on this board. And so far, we got barely anything. If you want to, you can kind of keep your population stuff together. So the variance for population would have the Greek letter, right? And what's that formula? I get it started off. Mu, good. For the population?
Squared over n.
Good. Stopped yourself. I like it. What's different for the sample? Besides it uses our letters? Good. And let me say this. I don't know if you noticed, but I have horrible handwriting. I don't know if you've noticed. When you're going to do your formula sheet, I would double check every formula you've written against what's in the book. Because I love it when somebody says, I just wrote it down from what you had and I thought it was this. It's not. Screw it. Go make sure it's the right freaking formula. Make sure you're not just seeing my writing wrong. It's up to you to have the right formulas down. All right, so that's chapter 3. Chapter 3 also gives us percentiles. You have to know that. There's nothing you can really write down here. I will let you, well, I don't know. This will probably confuse you more than anything. No. You have to know how to find the median. If you have a suggestion, you can let me know. I'll knock it down or not. Chapter 3 is where they introduce z-scores. You can have the z-score here. I'll let you have the word or in there. So you guys are like, thanks. Just trying to make a point. There will be people that are sitting in here right now that will still lose points on their freaking formula sheets. I just don't understand that. And you say, just don't take points off, Jeff. Nobody will lose points then. Anything else that I'm forgetting? I mean, I'd say mid-range you can put down there, right? That's fine. So there's a collection of words that are all in a formula. That's okay. Cool. That's a decent little collection of stuff. All right, so you can add that on your formula sheet. And I'm not one of those who requires you to put it on a little whatever. You can collect formula sheets. For the final, you can bring all the formula sheets from every test with you. Probably not the ones if you lost any points. You probably want to rewrite those. Yes, okay. I think it's really funny to make people, I'm always thinking someday they'll make you put it on a grain of rice and you have to learn. Have you ever seen those people? Learn how to put it and then bring, just so we can sit there and laugh at you. But I don't require that yet. A little bit later in life, I'm like, I need some entertainment. Why don't you put it on this size? But I'm not there yet. You can put it on reams of freaking paper if you want to. So it's just formulas. All right, so that's it for the formulas? No other suggestions? Okay, cool. All right. So it has been recorded. If somebody tells me I had something else up there, screw you. It's all right there. So now, let me maybe give you guys the answer key. That might spur some more conversation. Some of you guys this have had me before, but if you haven't had me before, the worst thing in the world you could do is this. Yeah. No, it's not doing anything for you. I would have done that. No. So you don't even look at this damn thing. You do the practice test, and then you check it. And anything you had a lot of trouble with, you go back to that section or you go get help, right? Or if you don't have time, you just don't do the practice test at all. Don't even look at this damn thing, right? It's not going to help you to agree with me. It's not going to mean you're going to be able to do it yourself. They should have one for you. That's yes. Sure. For Instagram, there has to be At least 5 to 10 plus. Well, thank God. Okay, good. I try to show in the frequency distribution what it will look like by the book in the inequality method I showed you. I did the histogram itself based off of the book method. Right? You guys with me? But if you do the less than or equal to x less than thing, then your scale would be different. It'd just be the whole numbers, 29, 36, so forth. If you do it the book way, you got to show me the class boundaries, right? My limits, my boundaries. Don't invade my personal space.
So if you do it like with one number and then another number, and then that number ends up on the next one, and you put that number in that bracket, right?
Because the last thing is less than or equal to x less than 36, for example. So 36 can't go there. The next one says, say 36 less than or equal to x. Oh, that's where 36 goes because it's allowed to equal. And that's why some people don't like that. Is they don't like inequality stuff. So, yeah.
If we only have like, there's a word for it, but like limited numbers, like it's only 39.6. It doesn't give you more like decimals. You have to do less than or equal to. Or can we just write like the biggest number is 39.6?
If you do it the inequality method, you have to do it that way, the way it is, all the time.
Okay, but if we do it the other way,
The book way?
yeah, do we still have to continue with the decimals, or are numbers or?
So the book way, there were some problems in the homework like this. So I was waiting to see if I get any questions on this. But if your data looks like 4.2, 5.6, so forth, then your classes are going to have to look like something like 0.0 to 2.9, 3.0. You with me? To 5.9. It's going to have to mimic that. It's going to have one decimal place.
We don't have to have more decimals than the other ones?
No, definitely. For whole numbers, we used whole numbers, right? Now, the beautiful thing is, my way would say, all right, the width is 3, so screw everything and just make it 0 to frickin' 3, because it captures any decimal. That's why I still don't understand why books use this. I'm sorry. If you like this, it's fine. You got it in the book, what the hell, but there's no need. Yeah?
When you do it on like a histogram based off that way, do you still put like 3.5? Like,
Oh, no, hell no. You mean on the graph?
yeah.
When I go to make my histogram, it's going to be 0. Well, 0 will be where it's supposed to be. 0 to 3 to 6.
And if you do it the other way, you have
This way, what you got to show here would be negative 0.5, not even that, 0.05, 2.95, 2.95. Yeah, that up and down by half has to go out following your decimal places. I don't know if you understand what I'm saying, but there were several examples like that in the book, several in the homework. So if I had, this would be like 2.95 here, right? You have your negative 0.5. If it was one more decimal place after that, 0.0 to 2.90 or something like that, this would be 2.905. Oh yeah. Yes?
When I'm making my classes, I have to start with the lowest,
No, that's another point of flexibility.
so like on that thing it's 29, but I started at 28. That's all
I love it. Kick ass.
That's good?
That's totally up to you.
Okay.
So you don't have to start, your last class doesn't have to end at your last data point. Some of you guys try to force that. Don't. And your first class doesn't necessarily have to start at your first data point. If my first data point was 11, I might start my first class at 10, especially if my class width is 10, that makes it easy, 10, 20, 30, right? But if you go too far back, you might start having to make another class than you wanted to. Does that make sense?
Yeah.
Yeah. That's what's going to make grading these so much fun, is there's going to be so much different possible answers.
Could you do an example of standard deviation?
Sure. Are you looking at one specifically, or?
I'm just looking at the one that we did for the notes.
Okay.
It looks confusing.
All right, so let's work with a relatively small sample size. Let's see. Oh, don't try to force anything. Nice, Jeff. Well, screw it. This is fine. Somebody help me out. This will be, I think it's 105 divided by 6 for the mean. Double check me there. Does that have to be 105? 30, 41, 60, 81, 105.
54, 64, 69, 79, 83, 93, 95, 105. Yeah.
Sweet. All right. So 105 divided by 6. All right. You guys with me? So we found the mean. Yes, sir.
For the true and false one, can you say explain it? Do you just want to see an example of like how it could be wrong? Or
Okay. So real quick, if it's wrong, you can always explain it by showing me that it's wrong, and sometimes that's easily done with an example. I love it. So like I did with one of them, I think, if I remember right. Yeah. So 6a, it said the mean, what did it say? The mean can't be the mode or something like that?
It can't be the same thing.
Can't be the same thing? So there's an example where it is. So that's the quickest way to show something is false, is to give a counterexample. Always. Truth statements kind of suck, because that means you got to explain it, then really explain it. Like you can't just do an example, that's not good enough. If I say every number a squared comes out positive, comes out even, and you say yes, 2 squared is 4. Well, you're wrong, because 3 squared is 9. No, too bad for you. So you can't prove something with one statement, but you can show it's wrong by giving me one counterexample. Kick ass. So now that I know the mean, how do I set this up to start doing the standard deviation? So what goes here? Good. I'm telling you, it's a sample. So I got to be very. If you can't find something, it's probably a sample. If it's a population, I have to be very explicit that it's a population, because what do we normally use in statistics is a sample. So if you don't know, if you can't figure it out, it's safe to assume it's a sample. I got to say very clearly that it's a population if it is. Where am I? Oh, so now what's 12 minus 17 and a half?
Negative 5.5.
5.5. Watch this. This is 2 up, so 2 up, 1 up, so that's 1 up. 4 up, so this will be 4 up.
2.5. No.
1.5.
Yeah.
And then 2 up,
3.5.
and then 3 up from there. Or, of course, you know you can use the calculator, right? L1, L2, you can define it. You guys kind of with me? I'm obviously not going to give you a list of like 80 numbers. But it's also not going to be a list of 6. It's going to be somewhere in the middle. So you're probably going to want to employ your calculator to help you. And you will have to show me the tables. What's the next thing over here? Okay, cool. So what's negative 5.5 squared? 30.25.
And then negative 12.25.
What's negative? Wait. Why are you coming up with negative? It's freaking me out. The square, it comes out positive. Now, don't hold it against your calculator. If you do this and it comes out negative, don't tell me your calculator doesn't know math or something. Yeah, exactly. If you got to square the number, here you're not squaring the number, you're squaring part of the number, and then leaving a negative on the outside. Yeah. So I love that when a student comes up and says, you know, I did this and my calculator tells me it's negative. I don't care what your calculator says, you're putting it in wrong. 1.5 squared?
2.25.
Yeah. 3.5 I know. And 6.5 I don't know.
42.25.
42.25.
Do you have to put the E in front of, or the, what's it called, the sigma?
You definitely don't put it here because that doesn't make any sense. Each one of these spots is that x minus the mean squared. When I add these up, that's what E means,
It's
right?
at the bottom. Yeah.
Yeah.
Okay.
And of course, it's the Greek letter S. So now I would say the sum of these is whatever the hell.
105.5.
That's neat.
Yeah.
Okay. That's coincidence, by the way. Don't try to extend that to anything else. It's always a half more than the sum. No. Sure. That is neat. Anyway, sorry. Yes.
If we don't put that formula in all the tests, we just put equals and then that number.
But that's fine. I'm just being very explicit up here.
Right.
Because now when you go to the formula requires, and this is where people just, even though I've said this before, I'm going to say it again, you cannot plug stuff in here. It doesn't make any sense because this is more than one value. So how the hell can you do that? This is the sum of these. When you did the sum of them, that number goes in place for this variable. That whole thing is a variable. For a different list of data, that variable would have a different value. Possibly, right? So it itself is a variable, yes.
For the test, you would have to put the original equation if you just plug it straight in and show you like the equation.
It's not a bad idea to put the equation down, especially because if you wrote it down, if you did it incorrectly, but I don't know what happened, you just wrote something down wrong, but if you don't write it down, I don't know, so I have to take more points off because I don't know what happened. The more you show me, the more I can tell what went wrong, the more chance you have for partial credit. If I don't see anything, I got to assume the worst. So here, in place of this whole thing, 105.5. Good, because there were 6 things. 21.1. That is the what? That's the variance. Beautiful. So to find standard deviation, I just
Square rooted.
square root it. Good.
Sorry.
4.59. Oh, 4.593 standard deviations.
4.593. Okay. So remember, a standard deviation has to have at least 3 decimal places. I will take points off if it doesn't.
You're going to take points off if we don't put what the, like if it's in millions, we put the million. So isn't the homework, it tells you to put the...
Oh, put the units down.
Yeah, the units.
It's funny that in this case, for standard deviation, I don't really care. I'm a big units guy because I'm a science person, and for math, and I always write. I'm the guy that says 4 bananas or 4 what, you know, when somebody. But I mean, technically you should, but it doesn't matter. Yeah. At the very end of the problem, you would put them in. I don't use units in the middle of my problem; they just get in the way.
Yeah.
Yeah.
For Z score, how many decimal places?
We're going to use a table very soon. Well, once we get to chapter 6, so I don't know if that's soon or not. That only goes out to 2 places. So you'll pretty much always see me making z-scores go out to 2 places. Yeah. The standard deviation, definitely at least 3 places. If you're not sure, just make everything 3 places and you're covered. Okay. I'll try to say, like on the test, I would tell you what to round this to so that you don't have too much or too little. So to kind of save you from yourself, I'll tell you what to round that to if it comes out to something freaky.
On your test number 9, I saw the price of gas listed at the gas station as also continuous because I couldn't see you having an exact number, so I kept thinking of it as being continually on. How did you get this I mean, I don't
So the gas station, the gas price listed at the gas station. This is why some of you guys, we got to be careful. Discrete is not whole numbers. Discrete means certain values. So the gas price, and if you really are pay attention when you go to the gas station, it's like what is it now? I haven't gassed up in a while. 70 something?
Yeah.
There's always that last little number. So it's basically 380 really, right? Can that gas price, can they list more than that? Is there room for it? Would they? So prices in general really have to go to, here they got the third decimal place. It's like the only place you ever see that, right? But it's definitely discrete, because they wouldn't say, I wouldn't say how much is gas here, and they would say, well, gas is $3 and 0.89722466693. Here, we got a calculator for it. No, they're not going to. Gas is about square root of 11. No. So.
Okay, so how it was listed is how it would be put on.
And actually, the price of anything would be discrete. People see the decimal place and they automatically think that means continuous. No, continuous means between any two possible data values, any other data value could be taken anywhere in between. It's continuous. Discrete would be 3799, 380, 381, 382. They're skipping an infinite number of numbers in the middle, right? Okay, maybe. I don't know if you guys realize that. How many numbers are between 0 and 0.1? An infinite number, right? So if you have 0, 0.1, 0.2, 0.3, it's not continuous because the decimal, it's definitely discrete because it is skipping an infinite number of numbers every time you go up. Good. Doesn't take down anything in the continuum. So that one I want to put down because price is a weird one, right? So I'm not going to put price down on the actual test. You're all like, no, I got that one down though. Yeah, I know. And then the other one, hopefully, you got to be real careful. I don't think I said this. I don't have. What did I say for 9B? What was the?
Weights of a bag of sugar. You said it was continuous.
Good. So you got to be careful. If I say a bag of sugar weighs 5 pounds, your answer wouldn't be discrete because it's 5. Because what could it be? 5.039467. And maybe I rounded it, right? But if I say I've got 5 kids, which I don't think I would have gray hair. If I said I have 5 kids, I didn't round, right? Well, Jimmy, we're not just sure about Jimmy. Dropped him a couple times, it's too bad. It's almost a kid. So that would totally be discrete. It can't take on any value it wants to. So just because I pick a whole number when I give a situation, you can't just focus on it and say, it's discrete because you gave me a whole number. No, you got to think, what could it be? Okay, good.
Maybe I didn't kind of look at it as the price that it was listed. I kept thinking gas could be, you could put it in, but you could go on and on and on.
Yeah, I was kind of careful because it depends on the units that come in, the volume, and they can divide it and get all weird numbers. But you can divide and get 2.5 kids on average. Nobody has 2.5 kids. It's just an average. Yeah. Huh? What's that? Oh, 2.5 men. Oh, yeah. Well, I would argue that there's really not 2 men on there. But it's more like 1 1/4. I don't know, something like that. I really added them up lately. Is that show still on? Really?
Yeah.
All right. It's got to be on its dying last legs. Any?
Sure.
Yes. 10? I like 10. I kind of wish I wouldn't have given it to you because I want to give it to you on the test, but too bad for me. So you can make up your own observational study. And the main thing about observational studies, what's the main thing that differentiates it from an experiment? You don't say experiment because I want to collect data. If I observe, I'm collecting data also, right? So that's not the distinction. What's the distinction? Good, manipulation. So when you say give a treatment, that's right, but you got to expand that idea of what treatment is. The one about the guy being angry to people when he was surveying, that was an experiment because he's applying a behavior and seeing how it modifies the other person, right? It's a treatment. I'm giving you a treatment of anger, right? Or the purple traffic light, if you say it's observational, that means you got to set up a chair and just hope somebody installs a purple traffic light, because you can't do it. That would be you affecting the environment. You just have to wait for it to happen naturally. It's not going to happen, right? So my example was how people act in line at a bank and how people in line act to react to a holdup. So you have to have somebody go in, probably have to talk to the bank and to the local police force. I'm not suggesting you do this. It's an experiment. My teacher said to do it. No. Like it's that guy. It's Jeff Waller. Shit. But that's an example of doing it. Anybody else have a different example that they want to share? Probably not. You guys are. Okay. I can live with that. Yes.
I have an example.
Sure.
I did placing a quarter on the ground, sample, pick it up, and then put it in the quarter and see the quarter.
Oh, okay. So you got to be careful because, again, that first thing. Why is that not strictly observational? Because you introduce something into the environment. So how could you? Well, let's see. That would be interesting. How could we change the experiment of putting coins down on the ground and seeing what people do? How can you change that back to an observation?
Go find one again.
Yeah, you have to find one that's laying on the ground. All right. You're like, oh, it just fell out, Jeff. It's the observation now. But it's easy to come up with an observation, I would think. You just can't. You just got to go. Just whatever's happening. Just say you're looking through something and nobody knows you're there. Just watching, right? And then how do you make this experiment? You introduce something. You throw something at somebody. You set up a rectangular-shaped stop sign. See what people do, right? That would be really
By
neat.
wishing well, and we'll see if anyone takes money out.
Huh?
Sit by wishing well and see if anyone takes
Oh
money
man,
out.
yeah. You could do that. That would suck if you actually
Observe.
found people doing that. Hold on to my ankles. I don't like it. That reminds me of the Goonies, actually. All right. So I like that problem. So what you'll probably go on the test is more like identify these and explain why. Maybe I'll think about it. Maybe I'll do something like this on the test. So just be ready for something like this. Yes?
Could you do like you could observe how fast you go through a full tank in a given amount of time, and then you could do an experiment by like looking at a certain place for gas, like looking at Chevron, like how long that lasts. You.
Sweet.
So would
That sounds so much like a Mythbusters episode. I love it. So just get a baseline. Just observe how you normally do. It's very difficult to do that. It's interesting because the minute you start thinking about doing an experiment, you might subconsciously change how you drive. So you might want to consider how to do that. But you could do it. Get a baseline and then introduce variables. And that's what they do in Mythbusters, right? That's this beautiful. They do a decent job of explaining the variables that they have to control for. Well, they did the one where they made the car look like a golf ball on the outside. They put putty on it and then curved it out so it looked like a golf ball. And I think they managed to get a little bit of a tweak. It was statistically significant, but not practically significant, let's just say. Otherwise, you see a lot of those cars on the road, right? Pockmarked cars. You don't see them. You guys just aren't used to this, are you? It's totally up to you. Whatever if nobody's saying anything, it's your floor. Whatever you had trouble with in the homework, whatever you didn't understand. Look at 8B real quick. I think that's the. Which one is that? Yeah, look at 8B. The biggest mistake people make, and there was a problem in this in one of the versions of the book, where it was like this many percentage of executives wouldn't hire you if you made a typo on your. So some of you guys did not have that homework problem because you had a different version of the book. How did they get a hold of that percentage, the 14%? Where'd that come from? That came from the sample. So if you say the 14% is the sample, that doesn't make any damn sense. I had to take a sample and then see what percentage of my sample did something specific. So don't tell me that 14% is the sample and the 183 is the population. That does not make any sense. How did I randomly pick the 14% that did this specific thing? I highly doubt that I would have done that. You with me?
Yeah.
A little bit? So be really careful. The 14% is really just a statistic. It's something I did to my sample of 183 people. Or 183, whatever it is. Yeah, not people, students.
So would population be the small? Like
students.
Good. Yeah, I can't remember exactly how I wrote it.
Yeah, it's Grossmont College students, right?
Good. You could argue that it's only Grossmont students who park, but even if you don't park, you still go to Grossmont, still interact with other people, still might have an opinion about it. So I'd agree if you argued that it was only those who park, but students at Grossmont is your population, all students at Grossmont. The key word for population is all. Very often you can replace the number with the word all. 183 students at Grossmont, all students at Grossmont. It's crazy. Yes?
So the sample would be the 183 students?
Beautiful. That would be the sample, yeah. Yes?
Okay, so there was a question in the book on 3-4 where for the standard deviation table, the numbers were too big. And you couldn't see the whole number on your calculator. What do you want us to do?
How do you mean? Oh, you
It
mean...
was a super long decimal.
Yeah.
We just keep it at 3 decimal places? 'Cause it goes
Oh yeah, definitely. You can cut that off.
Okay.
Yeah, I mean, in the calculator, you could not round anything. When you go to write it down, you could round it. Yeah, definitely.
And
Yeah.
then we could just take the sum from
Yes.
the chart still?
Yeah.
Okay.
Yeah. The less you round before you get to the end, the better the answer is. The less off you'll be. Yeah. Yeah.
What's the difference between mean and median?
Yeah. What is the difference between mean and median?
Mean is average, median is middle.
So which one would be affected by an extreme value? The mean would be affected because the mean sums up all the values and then divides by how many there are. The median just says, I don't care what your values are, tell me how many you got, and then put me right in the middle of the data, right? So the median doesn't care about the CEO's pay. It'll just go right in the middle, which would be much more accurate. Or home price, right? Income, home price, anything where it's extreme values involved. The mean takes all the values into account. So it could very easily be swayed by extreme values. Yeah.
Can you show me how to do the range for standard deviation?
You mean the range rule of thumb? Or...
No, I don't know. It just says range.
Yeah, so...
It says range rule of thumb.
No. Where does it say that?
1E. To determine the range.
Oh. Yeah, the range. Just the high minus the low. Right, you have to do that for the class width anyway. So by the time you get to that point, you've basically already done it.
Okay.
If you did the class width right, you've already done the range. You just got to take the number. So for this data here, the range would be 12. 24 minus 12. High minus low.
So what do you use the range rule of thumb for?
That's to estimate a standard deviation. If I know I have a normal distribution, this is kind of cool because it's a conceptual thing. If I know I have a normal distribution, where would most of my data be contained? Within how many standard deviations? 2 has a lot of it, but almost all of it's within 3, right? So if I knew that this data went from 3 standard deviations down is 10, and 3 standard deviations up is 60. Well, that's 5. That means that 6 standard deviations equals 50. Now, what the hell? Say it so simple. You kind of with me? 3 down, 3 up. So 6 standard deviations across equals 50. So what's one standard? What is the standard deviation? Divide 50 by 6. So if you divide from 3 down to 3 up by 6, you'll get an approximation for your standard deviation. The more normal your data is, the better your approximation is. It's not used very often, but I can't remember where it shows. It shows up in the book somewhere. I don't know if we've hit that yet or not. Okay. Cool? Yes? You know, I thought I brought everything with me, but I must have left the quizzes I didn't hand back in my office. So, that's my fault. Number 1 from the practice test? Okay. What about it? Oh, F. Oh, okay, so F is after you've determined your mean and your standard deviation. And it's that thing that was on the bottom of the handout we did together. Because we have, Chubby Dude, we have empirical rule that talks theoretically about the percentage that's in there. So I wanted to show you some concrete examples. Let me actually go count the freaking things. Don't tell me, Chubby Dude, empirical, all this theory. Let me go count this stuff. So if I knew my mean was, well, looking at the one we did. So 1F, we know here the mean was 45.7. Is that right? Well, 7 got cut off. And the standard deviation was, where'd you go, 8.575? So if you set up the range here, if you set up, put the mean in the middle, go one step up, where would you stop?
54 point.
Yeah, so you just add 8.575. So you go to 54 point, it's like 275?
24.
Yeah, doesn't matter, somewhere in there. And if you go down one, so 45.7 minus 8.575. Then you go where? You go to, I got 37.125. So is that cool by itself? Do you guys see what that means?
And then you would just...
Have all my classes gotten together? Do you guys get together in my other class and say, don't give them shit? Or we would practice your stone. This is like a Zoolander thing. You're all doing some kind of weird, this is what I call it, don't tell them shit. Yeah. So real quick. Sorry. So once you set this up, you just go count how many data points you actually caught. Right? So here I counted all the data, I listed all the data points that I caught. And that's why it's really good to sort your list. Makes this question a lot easier. I caught 11 out of the 15 things were in there, so that I can see what percentage is in there. So comparing it to the theory, does this look like it might be normal? I end up with 73.3% within one step. How many is supposed to be within one step if it's normal? Yeah, it's kind of far off from that, right? Of course, we don't have a feel yet for how far off is enough, far off enough. Yeah?
Is this a homework problem or practice test?
Practice test 1F. Okay.
I just wanted to point out on the study guide, under the little loops, you put plus and minus 15 versus the 8.5.
Oh, no, I put plus or minus 1S. My S's look like 5s. That's my bad. Yeah, plus 1 standard deviation, minus 1 standard deviation, yeah. Yeah. Oh, if you look back, number 3 actually talks about... Can I borrow that? Mm-hmm. For the sample and problem 2 above. 85 and 111, isn't that 2B and 2A? What was your answers to 2A and B? Good. So I'm asking in number 3 then, I'm asking what percentage of the data is within one step of the mean? Down 1, up 1, right? So, and I told you in number 2 that the data was normally distributed. I really want you guys with me. This is kind of important. Am I allowed to use empirical rule for that? Yes, because empirical rule is built for normal distributions. So what's the empirical rule say? If I go out 1 step up and 1 step down, I catch 68%. If I go 2 steps up and 2 steps down, 95%, so forth, right? 99.7 for 3 steps. You got to know those numbers. I'm going to ask you at least 1 question, if not 2, involved in that. Part of me wants to say, well, let's see. So real quick, everybody do me this favor. I don't think I did this with you guys.
Wait, you said
Where is it?
2
What's
standards deviation from the mean is 68?
1 is 68. 2 is 75.
And 3 is 89?
Sorry, 3 is 95, yeah. I'm thinking,
3 is 95?
I'm looking for something. Yeah, so 1 is 68, 2 is 95, 3 is 99.7. Good, so you got to remember this. I'm trying to see if they have the formula.
I don't know why my numbers are so.
All right, here. On the one hand, I really, really love it when you guys don't accept just what I say. I love it. This is what you should be like. But let me show you part of the math involved to getting those numbers. And then maybe I'll convince you to just memorize those numbers. So what it says is, now obviously with the shape, there's no way in hell that within one step can be nothing, right? There's got to be something. Let me put my z-scores down there. Is that cool? And there's got to be a really good chunk in the middle because the highest point is the mean. So the interesting thing for a normal distribution, the mean equals the median equals the mode. It's the middle of the data in every sense for a normal distribution. It's kind of cool. Why are you showing me nothing? Did they have this problem last time? Oh, you have to reboot it. If you have the new book, page 238, I know that's chapter 6. Just turn there. There we go.
Well, that's the empirical rule, but for number 3, because you
all right.
normal distribution.
Just look at that. Look at it. Just look at it. This is, if you put this into your graphic calculator, and do you notice any symbols that look familiar?
Yes.
Yes. Mu, sigma, pi, yeah. But mu and sigma are stat stuff. So if you pick the mean and you pick the standard deviation and you put it into y1 in your graphing calculator, it would graph you a normal distribution that has the mean you picked and has the standard deviation you picked. If you graph this. So if you did calculus on this, calculus, has anybody taken calculus? So a few of you guys know what I'm talking about. If you found the area between -1 and 1, z-scores, if you found the area between one step up and one step down, it would come out to be 0.68 something, right? Basically roughly 68%. So that is the, I really want you to understand, you don't need to understand this formula. We're not going to use this formula, so don't freak the hell out. Don't leave before chapter 6. If you graph this formula, it looks like a bell curve. In fact, it is the definition of the Gaussian curve, the bell curve. And to find the area underneath some parts of the curve, we use calculus. It's one big thing that calculus does is it calculates area. Does that mean you have to know calculus to do this? No. We're going to stand on the shoulders of all these number crunchers and just take what they got. And one way we do that is to take their 68% they got and just use it. Thanks, guys. So on one level, that's the best answer I can give you right now. Some of you guys, we could actually do more. But some of you guys might realize that's like e to the x squared, which is an impossible integral to do by hand. Unless you use series, and then you need calc 2. Sorry. But that's where those numbers came from. It's from that formula, finding the area underneath, because that's really what's going on. The whole area here would be 1. 100%. So the area between here is 68%. 95, 99.7. So now just memorize those. You don't have to know this at all. Don't freak out about that.
So for number 3, would a good enough explanation be empirical rule?
Yeah, by the empirical rule, 68%.
Okay.
Yep. So a real quick example of a problem I can give you related to empirical rule. If I know I have a normal distribution with a mean of 121.7 and a standard deviation of 4.2, what percentage of the data is between, what you got, Jeff? What are you doing in your head? Let's find out. 113.3 and 130, no, 120 to 130.1. Let's find out if I did that right. Yeah, well, how'd you get that? So you got your 121.7 is the mean. If I go one step up, that would be plus 4.2. You guys cool with that? I've done this several times. Is everybody decent with what the hell I'm doing here? In fact, I know this is normal, so I could even draw a little normal curve over there if I want to. That had a rough day. All right. So plus 4.2 would be 120. Yeah, and then plus another 4.2. 130.1. Yay, Jeff. All right, and one step down, minus 4.2, and then another step down, minus 4.2. That should end you up at 113.3. So what percentage is between those? 95%, because you know it's normal, so you can use empirical rule. If I didn't say it's normal, if I just said some distribution has this mean and standard deviation, what would you have to use then? Chubby dude. Chevy Chev. And then he would say within 2 there, so who remembers? 75%. I'll just tell you this directly. I'm going to focus on empirical rule. I'm not going to really focus on Chubby dude. All right? Chevy Chev. So all I got to do is if I give you this kind of problem, just make yourself a quick visual out of what I've given you. Step up and down several times, and you can answer any question I ask you. What percentage would be up here? No. This is where you got to... Yeah, what percent? And careful, what's in here? 68%. You with me? So how much is outside? So how much is on that side? 16. Let's do that again. Because up here has not a damn thing to directly do with the empirical rule. Empirical rule tells you very, very little. Chapter 6, we're going to know, I call it empirical rule on steroids. We have this table that fills in if you're there, I know. If you're there, I know. If you're there, I know. But right now, I got to be there or there. And I have to be in between. That's it. But up here, I just got to think, well, empirical rule is 68%, which means there must be 32% out. It's symmetric, so there must be 16% up there. We did a little problem like that when I was talking about the tall dudes and what percentage would have to duck if I didn't make the door tall enough. You can actually use this to do it because heights are normally distributed.
So what is the difference between the empirical rule and the Chubby?
Good.
Whatever.
Chevy Chev works for what kind of distributions? Any. That's why his first statement is there might be nothing in there, because it might be nothing in there. It might be the weird-ass distribution that has everything really far away, just far away enough so that you go one step out, you don't catch anybody. So that's why his first statement is kind of lame, at least nothing. But then you take one more step out, I don't care what you make it look like, it's got to catch at least 3/4 of the data. 75% is crazy. Empirical rule is specifically for normal distributions. That's why all the percentages are much more precise. I don't say at least 68%, I say 68%. Because it's got to look like a bell, it's got to be symmetric, it's got to have the highest point, it's got all these restrictions on it that it can be much more precise. Now, we can't always use it, but it's our goal for a lot of problems because then a lot of our work is simplified. If our distribution is not normal, Chevy Chev is nowhere near detailed enough. I have to do very strange things sometimes to calculate stuff on non-normal distributions. So a lot of this class is, when can you say it's normal? What can you do if it isn't normal? How can you kind of normalize it? You know, there's things you could do. Because then everything's simpler. Right? This is a specific answer. There is 16% above 125.9. Period. So if I had 80 people coming, how many people would have above this IQ? Let's say these are IQs. 16% of 80 people. That's what I can kind of... I won't put money on it necessarily, but I know it's going to be around there. I got a really good chance it's going to be around there. Maybe. Yes?
So what you gave us, this is basically the exact form of the exam, right? Just changed up problems, like in the wording a little bit. This is the exact, like, same form.
I wouldn't necessarily go that far normally, but for this first test, it's very kind of prescribed. There's definite questions you can expect from me related to Chapter 1, right? Definition stuff. And then I'm going to ask you to make a histogram. I'm going to ask you to find standard deviation and variance and stuff, right? So this first test, pretty much, it's going to be like this, very much like this. I'm infamous for telling you guys to, from a big list of data, select your own data. So I really love it when it just happens that two people near each other have the same exact data points, because the probability of that's very low. So what's more likely is they got them together. Yes?
How many problems
Like on the practice test, I would say there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23, 24, 25, 26, 20. I'd say there's 27 problems. Because I hate it. The teacher says there's 4 problems, and they all have A through J. That's not 4 freaking problems. So normally on a test, 24, somewhere around there. It's a little bit tiny shorter than this. Bless you. Yeah.
Maybe just do a small example of their relative unit.
Sure. Let's see. All right, so a little set of data. You don't have to write this down if you don't want to. How do I find my class width? How many classes do you think I'm going to want to use here? 5. Good, good. If you use 6, I won't take any out, but if you use 8, what the hell? What, 5 classes? How do I find the width?
I minus low divided by how many
Good.
classes?
High minus low. The range divided by, in this case, 5, but it's not always 5. I saw some people doing some homework where it was always 5. It's not always 5. Yes, sir.
But this one, why 5, like right off the bat, just by looking at it?
Very small sample size.
Okay.
Right? And I'd say, roughly small is below 30. And then medium is like 30 up to 50. And then above that, you can start using 7, 8 classes. Again, if you get to a point where you need to do this for your job, then there is a natural log kind of algorithm. You take the natural log of the number of data points and do something with it, and it tells you how many classes you should use. But for us, we're going to basically use 5 or 6 for what I give you. Right? I'm not going to be giving you some huge data set. So what's the highest? So I put them in order. That's nice. 37 minus 10. 27 divided by 5 gives me 5.4. So round up to 6. Real quick, divided by 5, double this, and then divide by 10, right? 54 divided by 10, 5.4. Easy. Easy to divide by 10. It's a really cool little trick for divided by 5. So now, what are my classes going to look like? So again, like somebody said, you don't have to start at 10, but 10 is a decent number to start at. Right? So you can go, if we do it by the book, that's 10. What's the next one? 16. So what's that going to have to be? If you do it the other way, you'd say 10 less than equal to x less than 16. Then 16 less than equal to x less than 22. Do the book way, this would be 21. Good. So I just start doing 6s. 22, 28, 34. And then 6 is here. 27, 33, 39. Now I catch everybody, right? 10 has a place to go and 37 has a place to go. Don't make this 37. Let it be whatever the hell it is. 37 just goes in there. So real quick, how many are from 10 to 15? 2. 16 to 21? 3. 22 to 27? 1. 28 to 33? 1. Get in there, 1. 34 to 39? 4. So is this a normal distribution? Hell no. right? Quick little check, 5, 6, 7, 11. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thank God. Right, really sucks. Do that check, though. If you can't find the number, just go to the next one. But at least say something like, well, let me not do that too. This is 11. If you add them up, you have 11 data points. If you get, like, I give you 30 and you get 29, just say, I can't see which one I missed, Jeff. I'm sorry. At least say something. If you don't say a damn thing, I'm like, you're not concerned? You got to check that. And at least show me the concern. If you don't want to waste time redoing the whole problem, don't. Just say, I missed this earlier. I don't know what I missed. I'm sorry. Cool. At least I know you paid attention to it. And I don't blame you that much for not redoing all the work if you didn't notice it until later. Notice it first, though. Right? And now this is my frequency. How do I make my relative frequency? Yeah, so this would be 2 out of 11? 18%? 3 out of 11? 1 out of 11? 1 out of 11. And then 4 out of 11.
36.
And if you add those up, you get something. You get 99. 5, 4, 3, 9. Yeah, you get 99, which is fine. Because I think in every case you had to round down, just about. How are we doing? If you get 95% or 104%, that's way too far off. Should be within 1% roughly. That would be fine for your approximations. Is that cool for the person who asked that question? Is that good?
For the, do we have to write that up on the left side, or is it just...
No, it's one or the other. If you do it this way, do it this way. If you do it the other way, do it that way. It's fine. You pick. Just if you do it this way, what's your scale got to look like for the, what's your first thing going to be? 9.5. Don't put 10. Don't get all hopeful. That's only for the people that do this way. Right? It's too bad. You got to use those boundaries if you do this. Those are the limits. So it'll be 9.5, 15.5, and then you just keep adding 6 now. Once you got one of them, actually, just add 6 because that's the width. Cool. I like it. Yes, sir.
How do you decide how many classes to use?
For us, you almost can't go wrong right now with 5. If you wanted to use 6 for some reason, you probably could and be fine. More than that, it's no good. Enough people have asked me that. I'm curious if this book has that rule in it. Because I actually never really used that rule myself. I don't think they do. No. No, I don't see it. Okay. It's fine by me. You guys look at me so funny. I'm about to say something that might clear the room because some of you guys are looking at me like, please. If you're ready for the test, you certainly have no reason to stay and stare at me and drool. Right? So stay if you want to absorb whatever people are asking, if you have other questions. If you are ready for the test and you're going to make an A on that damn thing, you can head out.
Since you're kicking us out, I guess.
I'm not kicking anybody out. Please stay if you need help. That's the whole point of today. Yeah. Okay. Oh, okay.
Can you get the answer key? I think you gave it to them when I wasn't being just
Oh, I didn't bring them with me. Oh, you have the corrections. You want to ask me if they're right?
Yeah.
You're going to have to wait. Sorry.
Yeah, I kind of just had a quick question about this. So this way is what we write down, because I was doing it your way, but I lost my notes.
Oh, yeah.
From
So
the
you're going to do it
beginning.
this way?
So it's like this is this.
Yes.
Right?
So it's
Okay,
one or the
just
other.
right.
Depends on
Okay.
you.
Okay.
Is it order or ratio?
Yeah, so if I stop 2 cars one day and then 4 cars the next day, I stop twice as many. So it's ratio. 4 divided by 2 would make sense. 0 would mean the absence of cars. Yeah. So
Can I write those formula on the test?
On a formula sheet, bring it with you. Yeah.
Doesn't matter. Okay, thank you.
Cool. So we looked at that number 3 earlier, but it's the mean was, what was the mean on number 2? $98, right? And the standard deviation was 13. Is that right? Yes. You with me? So the mean is 98. In problem 2A and B, I had to figure out for 111 and 85. And we figured out that a 111 had a z-score of 1, and 85 had a z-score of -1. Right? That's 2A and 2B. So that tells me it looks like this. Those are one step away, up and down, from the mean. What does empirical rule say about the percentage that's within one standard deviation of the mean? 68%. Done. No work to do. It's a theorem that I need to know. A rule, the empirical rule. So it's 68%. Because number 2 says a very specific word. What kind of distribution is it? Normal. Since it's normally distributed, I can use empirical rule.
How can you know that it's 68%?
Because it's normally distributed, and that's what the empirical rule is all about. So that was what I was trying to say. It was a really good question. Something I had earlier. That's why I showed that formula. That's the formula that actually would draw that. If I put it in my calculator, it would draw this shape. So that's a formula that regulates that shape. And if I calculate the area under that formula from 1 down to 1 up, it comes out to be 0.68, roughly. So it's 68% within one step. Cool. Yes, sir?
Can we do another variance of standard deviation?
Okay.
Am I still able to turn in the quiz? Correct?
Yes, do next time.
Next time? Okay.
Yeah.
Thank you.
All right, let's do this on the calculator here. Let's see. Here, you guys help me out. Let's make a list of data that we think is going to have a standard deviation of like 5. So I'll start us off. Let's say that's 2. Let's say I'm going to make 6 data points. And I want to have a roughly a standard deviation of 5, which means I want the average distance from the mean to every data point to be about 5. So the furthest ones would be a little more than 5 away, and the closer ones would be a little less than 5 away, right? That would even make it maybe a little bit normal. So if I said 2, 4, 8, 9, I don't know, and 13, 15, or something like that. I might have went a little too far. It's too bad. So the mean would be somewhere right in here. So these are really close to the mean, and these are a little bit further away. So it should be on the order of like a standard deviation of 5, very roughly. You guys kind of with me? I'm not going to ask you that question. That'd be really difficult to do, to set it up. But it's not going to be 1. Standard deviation is definitely not going to be 1. It's not going to be 20. Right? So this is going to be somewhere close to 5, maybe. So how do I find the mean?
Add them all up.
Yeah, so if you add them all up, you get 14, 23, 36, 51, maybe. And then divide it by 6. Be something or other. 8.5, I think. Yeah. How are we doing so far? Okay, cool. So those are my x's. I know that my mean is 8.5. So what do I want to make L2? What do I want that next column over to be?
X minus.
X minus the mean.
Yeah.
So it'll be, all my x's are in L1. So I want it to be x.
And highlight too. Are you putting in?
stupid me. So I want it to be x minus the mean. That's what I want list 2 to be. And those would add up to be 0, right? I happen to make this perfectly symmetric, so it's really easy to see.
They always add up to be 0?
Yeah, unless you round it, and maybe they'll add to be 0.1 or negative 0.3 or something, but it's got to be really close to 0. Yeah. It makes sense, because I'm subtracting the mean, which value-wise is in the middle.
Mm-hmm.
So it'll always have equal amount negative and positive on both sides. So what do I want to do, L3? L2 squared. I want to square that x minus x bar. Right? I want to get to the point where I can add up my x minus x bar squared. So L3 will be L2 squared. Bam.
What did you put in for to get the second L2?
So for L2,
You put the second
so remember, this here, right? Because our goal is to get that so I can sum them up. So then this number I can put into the formula, right? You with me? So our goal is to get here because our formula says it needs to know what this sum is. So I need to first create these so that I can add them up. So if I make x minus x bar and then square them, I can add them up and put that sum on top.
So what do you plug into the calculator?
All right. So what's it say? What's the second column got to be? All my x's minus the mean. The mean is 8.5. Where are all my x's at?
L1.
Beautiful. So I want L2. Highlight L2. I want it to be